Good morning. In this video, we're going to do section 7.5, which is recursive rules for sequences. So a recursive rule is just a different way to write a formula for some kind of sequence that's going on. So what a recursive rule does is it states something that's happening over and over and over again to the data. So are you adding like 5 over and over and over again? Are you multiplying by 3 over and over and over again? So what's always happening to the term before it, and is that constant? And that's a recursive rule. So there's a different way of writing it. Instead of using these are called explicit formulas. Okay, so those are explicit rules, I guess. And then we're going to be writing recursive rules. The difference with recursive rules is that you must include what the first term is. So you can't just say, I'm going to add 5 over and over again. So you can't just say, oh, okay, I'm going to add 5. We're going to add 5 to what? So you have to include whatever the first term is. So it could be 1, 6, 11, 16, or do you start at 2, 2, 7, 12, 17, or does it start at 3 and add 5 every single time? 8, 13, 18. So when you're doing recursive rules, the first term must be included. Okay, so include first term. I'm just going to put A1. And then this is new terminology. So this A of n minus 1 is the term before the A sub n. So this, just read it as the previous term in your head, and then it makes it a lot easier. So the 1 before the n. So if an is 1, the 1 before it is 0, the 0 term. Okay, so this just means the previous term. All right, so for this problem, they tell you that the first term, they're actually giving you the 0 term, is 1. Okay, so that's the first term. This means I'm going to take the previous term and add 4. Or the previous term plus 4. So if I have the first term, this is where I'm starting. This is telling me to take that term and add 4 to it. So the next one would be 5, because I'm going to add 4. Then I'm going to add 4 again. So then I have 9. And then add 4, and then add 4. 1, 2, 3, 4, 5, and then add 4. So this means previous term plus 4. For the next one, here we go, or you can try it if you'd like before I show you. So this is just a different notation. Instead of A sub n, they're going to use f of 1 or f of n. So they're telling you that the first term is 1. And then this formula is telling me 3 times, so the n minus 1 means the previous term. So it's 3 times the previous term. So I know where I'm starting. And then I know what's happening to my sequence, which is I'm just multiplying 3 times the term in front of it. So you multiply this by 3, then that one by 3, by 3, by 3, and then multiply by 3. Okay, so those are your first 6 terms. Go ahead and try the next 2. Pause the video and see if you can come up with the answers on those. All right, so again, this is where I start. And then this is 1/3 times the previous term. So I'm going to start at 81. And if I'm multiplying by 1/3, really what you're doing is dividing by 3. So it's almost like this one backwards. So if I divide by 3, if I divide that by 3, divide by 3, divide by 3, and divide by 3, or multiply by 1/3, the next one would be 1/9, then 1/27, 1 over 81, 1 over 243, and so on. You just multiply by 1/3. If you multiplied 81 by 1/3, by the way, you would get 81/3, which is 27. For the next one, this is the first term, so we start. And this is saying the previous term. That's the previous term. So f of n minus 1 is the same thing as a sub n minus 1. Okay, so the previous term minus 6. So you're just subtracting 6 here, and then subtracting 6 again, until you get 6 terms. Okay, so you just do this every single time to the term in front of it. All right. For the next ones, they're exactly the same thing as we just did. So pause the video, and then I'm just going to go ahead and write in the answers. Actually, I'm not just going to write in the answers. I'll explain them because especially 3 and 4 are a lot tougher. For 1 and 2, I'll probably just write them in. For 3 and 4, I'll explain a little bit more on how to do them, but you guys go ahead and give them a shot. All right, so hopefully you paused and did those. So I'm going to go ahead and do 1 and 2. I'm just going to do them right here so I can give myself some room to do the other ones. So for number 1, we start at 3. And then this is the start. And then this means the previous term minus 7. So I'm going to subtract 7. So we have -4, -11, -18, -25, and -32 because you're subtracting 7 every time. For the next one, we're starting at 162. This is the start. And then we're doing 0.5 times the previous term. So that just means half of that. Okay, so you can multiply by 0.5. It's probably easier to just divide by 2 instead of using 0.5. But if you want to use decimals, that's fine. I'm going to use fractions because it'll be easier. It'll be less numbers. 81 over 2, 81 over 4, 81 over 8, and 81 over 16. Yes, those are decimals. This will be 40.5, 20.25, 10.125, I think. And I can't remember the last one. So it's going to be 5 point something for the last one. Now for the next ones. These are a little bit tougher because of the way they're phrased. So I know that the first term, or the 0 term in this case, so f of 0 is equal to 1. Now, that's the start. This means the previous term plus n. So the next term will be f of 1. So the previous term is 1. And then we have to do plus n. N is this guy. So that's 1. So this term is equal to 2. Okay, so the first term was 1, the second term was 2. You might think that the next one's 3, but you're going to have to do the work. So for the second term, we do the previous term, which is 2, plus n, which is also 2. This is n right here. So now we're at 4. Let's see if you can come up with the next one on your own. So f of 3 is the previous term, which is 4, plus n, which is 3. Okay? So if you can kind of look at it this way, 0, this is going to be 0, 1, 2, 3, 4th term, 5th term, 6th term. So this is going to be a 4, a 5, and a 6. And this, because this is f of 4, f of 5, f of 6. Actually, that's going to give us 7 terms because we started at 0. But this number is always the one that we had before. So if that's 7, then that has to be 7 because that's the previous term. And if this is 11, then that has to be 11 because that's the previous term. So it's going to give me 16. So these are the numbers that are in my 1, 2, 4, 7, 11, 16. And then the next one would have been 22. We only need 6 terms. Okay, for number 4, we have the first term, which is 4. I'm not going to rewrite that. And then the formula or the rule is 2 times the previous term minus 1. Okay, so the first term is 4. The second term is 2 times this previous term minus 1. So that's 8 minus 1, which is 7. Okay, so first term 4, second one 7. For the third term, we have to do 2 times 7 minus 1. So it's 2 times the previous term minus 1. Okay, so that's 14 minus 1, which is 13. So 2 times 4 minus 1. 2 times 7 minus 1. So the next one's going to be 2 times 13 minus 1. So it's going to be 25. Okay, so then that's 25. The next one will be 2 times 25 minus 1. Okay, so 50 minus 1. And the next one's 2 times 49 minus 1. So these are your numbers, and it may or may not have been difficult for you, but that's how that goes. All right, continuing on 7.5. There's recursive equations for arithmetic and geometric. So we've already done these in explicit rules, which are the ones we did before. The ones that are recursive rules for arithmetic, this is the one where you're adding or subtracting the same number over and over again. And geometric, this is when you're multiplying or dividing the same number over and over again, are really easy to do. So again, arithmetic series, sequences, have a common difference, and geometric sequences have a common ratio. So here are the formulas, super easy to do. The only difference is that you must state the first term before you write those formulas. So there will be 2 parts to your formula. Otherwise, when you're saying, oh, add 6, and you don't tell your reader what your first term is, then the sequence is arbitrary. You don't know what it's going to start out. So there's 4 problems here. I'm going to do 2, and you're going to do 2, and then come and check. So for this one, they're adding 10 over and over and over again. So the common difference is 10. So when you do this problem, you just have to say that the first term is 3. And then the rule is the previous term. This is how you write the previous term, plus 10. Because that's how they do this sequence. They just start at 3 and then they keep adding 10. And so that's all you have to write. That's this kind, plus D. For the second kind, they're not adding the same number over and over again. You should be able to tell that. So you're going to have to check for multiplication. So in this case, to find R, you're going to have to divide the second term by the first term, or really any term divided by the one in front of it. So you can do 100 over 40, 40 over, and they're all going to give you the same answer. So 8 goes into 40, and 8 goes into 16. So 5 halves is the common difference. And if you check the other ones, they'll turn out the same. So if you did 100 over 40, these 2 numbers, you would get 10 over 4, which is 5 halves. So R is 5 halves. So this is the formula. The first term is 16, and that's really the same thing as 2.5. And then the rule is, 5 halves times the previous term. If you use 2.5, because 2.5 is exact, that would be okay. Now, if this was 1/3, and you use 0.3, that would not be okay, because you would not get these numbers. You would get numbers close to those, but they would not be exact. So just go ahead and use the fraction on that. So go ahead and do these 2, pause the video, and then come check them when you're done doing both of them. All right, so I'm going to go ahead and do this. I'm assuming you finished them already. So from here to here, they're adding 5. From here to here, plus 5. Okay, so D is equal to 5. The numbers are getting bigger. So the first term is negative 11, and the rule is the previous term plus 5. For the next one, they're getting half as small every single time. So 12 over 24 is 1/2. So that's R. So the first term is 24. And the rule is 1/2 times the previous term. Or the previous term times 1/2 if you want to do it that way. Some of you may have written it the previous term over 2, and that's fine as well. Again, the n-1 when you write this is a subscript. Okay, so it's a, and then that's a subscript. This is a sub n, this is a sub n-1, if you really wanted to write it or say it accurately. All right, so hopefully that makes a little bit more sense. Let's go ahead and try the next part. These aren't as easy. They'll be a little bit tougher. So for this one, it's not arithmetic or geometric. Like you're adding 0, then you're adding 1, then you're adding 2, then you're adding 2, and then you're adding 3. So it's definitely not arithmetic. They're not multiplying by the same thing, but there's definitely a pattern here that we wouldn't be able to write otherwise if we didn't have these recursive rules, or it would definitely helps. So I don't know if you can see the pattern here, but if you add 1 plus 1, you get 2. If you add 1 plus 2, you get 3. If you add 2 plus 3, you get 5. If you have 3 plus 5, you get 8. So the next one would be 5 plus 8, so it would be 13. The one after that, you would add 8 plus 13, so you would get 21. The one after that, 13 plus 21, so you would get 24. So what you're doing is you are adding the 2 previous terms to get the next one. Okay, so we're adding these 2 to get that one. So every time you're going through this, to get the 5, you have to add the 2 previous terms. So how do we write that? So to write that, the formula is the 2 previous terms. So it's the previous term plus the one before that. So if this is the previous term, this is the previous term, the double previous term, or 2 before the one before this one. Okay, so this is the formula. However, because we can't just say, okay, well, the first term is 1, because then you don't know what the second term is to find the third one. So if you wanted to add these 2 together, we can't do that. So if you're going to use the 2 previous terms, you have to start by telling the reader what the 2 terms are that you're starting with. Okay, and then you can do it that way. Okay, I know this is a little bit more difficult, and if you don't get this part, that's okay. Try to at least be able to, if I gave you these 2, to come up with the terms that were there. So the 2 previous terms added together give you the next one. All right, let's try the next one, and we'll do this one together as well. All right, question B is going to be tougher, and I'm going to write these numbers out a little bit more so you can kind of see what's going on. So here we multiply by 1, then by 2, then by 3, and then by 4. But how do we write that down into a formula, which will be a little bit tougher? So you could say that this is the previous term. So A1 equals 1. So A2 is equal to the previous term times times 1, but 1 is, well, I'm just going to put the number 1 here for right now. We can't just change the formula, and you'll see what I'm talking about. Then A3, the third term, is equal to the previous term. So this is times 1. This one's times 2. So the third term is equal to the previous term. Why can't I get the black ink? Is equal to the previous term times 2. Okay, now if I go to the fourth one, then it's equal to the previous term times 3. We can't have these numbers change in our formula, so we have to tie them to the letter n. This is n, this number here. So if that's a 2, that's a 1. If that's a 3, that's a 2. If that's a 4, that's a 3. So the way that we write this, if this is n, then this is n minus 1. So it's the previous term times n minus 1. The other way you could do it, if you didn't want to write it that way, a1 is equal to 1, you could say that a0 is equal to 1, and then you could say that an is equal to the previous term times n. Okay, so if this was a0, a1, a2, a3, then these numbers would match up. And so you could just use n. Don't worry about it too much if you don't understand that one. Go ahead and try the next two. If you don't get them, like I said, don't worry too much about these. It's okay. Pause the video and see if you can get them. If not, again, don't worry about these kind that much. Okay? So I'm going to go ahead and do this one. So we start with 2. This one is 2 squared. This is 4 squared. This is 16 squared. And this is 256 squared. So we start with 2. And then the formula is you take the previous term and square it. Again, don't worry about it if you didn't get that. These are tough. Okay? This is just like this one. You take the 2 previous terms and they add up to that one. So the 2 previous terms added. So it's exactly this formula. We just have 2 different numbers to start with. So the first term, the second term, and then the formula is to add the 2 previous terms together. Okay, don't worry about these 2. Let's skip those for now, and we'll go ahead and go on to the next part. So we're going to go back and forth between explicit and recursive. Okay, so in order to do that, you just need to know the difference, obviously. So, and I'll just show you. So this is explicit, meaning that you don't need to know what the first term is. You already know what the formula is. Okay, so for the recursive rule, all you need to know is, since this is in this format, like in the y equals mx plus b form, then that's d. So d is equal to 8, and you need to know the first term. So the first term would be, a1 would be 8 times 1 minus 6. So a1 is equal to 8 minus 6. So the first term is 2. So in your formula, you would say, okay, the first term is 2. And the formula is the previous term plus 8. Okay, because it's always the previous term plus d when it's arithmetic. So this is your answer. So it's the same exact sequence. Regardless of which one you do, if you were to write these out, you would start with 2, the next one would be 10, then you would add 8 to that, then you would add 8 to that. And if you wanted to know the fourth term, which is 8, 4, you would put a 4 here. And you would say, okay, 8 times 4 is 32, 32 minus 6 is 26. So you can get this sequence regardless of if you use the explicit rule or if you use the recursive rule, okay? The next one's geometric, which is a1 times r to the n minus 1 power. So r is equal to 1/2. The first term is equal to -3. So to write it as a recursive rule, you would just put a1 is equal to 3, and the formula would be the previous term, or I guess r, times the previous term times a to times n minus 1. Okay, so arithmetic would be, well, this one. And geometric is r times the previous term. Okay, so you guys go ahead and try the next two. Pause it and then come back. All right, so for the next ones, the d is equal to -5. Again, this is d. The first term is equal to -5 times 1 plus 30. So that's -5 plus 30, which is 25. So your formula would be A1 is equal to 25, and it's the previous term minus 5, not plus 5. In this case, A1 is equal to 7, R is equal to 2. So A1 equals 7, AN is equal to R times the previous term. And that's all you really have to do there. All right. Next, we're going the other way around. Okay, so to go the other way around, it's pretty easy as well. So the other way around, we're going from recursive to explicit. Okay, so in order to do arithmetic and geometric, so when it's arithmetic, you need A1 and you need D to do explicit. Okay, so D is equal to that number, the number that they either add or subtract to the previous term. So this is D, and then the first term is obviously given. So the first term is -5. So your formula will be -2n, and then the number that you go from here to here, remember to figure out what we're going to add. So basically you're saying, how do I get from -2 to -5? You have to subtract 3. So if I plug in a 1 here, then -2 times 1 minus 3 gives me the first term. And if it doesn't, then you have the wrong number here. Okay, D is always like the slope. It's the number in front of n. Okay, I don't know why I put a 5 there, because that's a 5. It's -3. So this is your answer. This one is geometric because there's a number multiplied by the previous term, so that's 2. The first term is 10, so the formula is just 10 times 2 to the n minus 1 power. And that's really all you have to do. It's AN is equal to A1 times R to the n minus 1. And these should be the last two, so go ahead and try the last two problems here, and then that's it. So pause the video and go ahead and do these two. All right, so we have AN is equal to 4n. In order to get from 4 to 7, we add 3. That's your answer. For the next one, we have A1 times R to the n minus 1. And that's it.